this year, 2015, we're projecting $3.4 billion. So, I'm going to skip all this, making a case for BIM. I think our approach to BIM, yes, BIM is technology, it helps us, but technology, we'll talk about that in a little bit. So BIM for us is just a tool, not more than a tool, and it takes probably 20% of the entire project's life cycle. So what's lean? Lean is actually eliminating of waste. If you find this book, please go acquire it, read it. It's the machine that changed the world, how Toyota actually produces cars. Read that book. You will get a lot of benefit from how Toyota has streamlined their manufacturing process, the assembly line, and how they've been able to eliminate a lot of waste. So what's waste? These are all types of waste. You know, all these 8 waste, maybe I'll highlight a few of them, right? So, yes, on Sunday we were supposed to start 7 o'clock. We started at 7:30, 8 o'clock. So we wasted a lot of time, right? So time as a factor, as a resource, can be wasted. And if you're just waiting, right? So that's a wasted resource right there. If you have inventory, if you have a lot of cement, rebar on the job site, somebody has to keep track of it. Somebody has to, you know, move it from one place to the other. That's a lot of waste. So I'll skip that. I think if truly, just because of, you know, the interest of time, truly try and go find these 8 deadly wastes and read about them. It will open your eyes, not just from a professional perspective, but even from a personal perspective at home. So even at home, if you have kids, you have brothers, sisters, your father, your mother, it's going to help you in your relationship with them, and it's going to help you streamline your personal life even. So I highly encourage you to go read the machine that changed the world. So, some of the things that we do, or the practices of lean, allows us to look for continuous improvement or not accepting good. We only look for greatness, right? So always, always look to do your best and achieve greatness and not settle for good. And this is the process we go through from a lean practice perspective to achieve continuous improvement. We do a lot of analysis and mapping for the process and how projects get delivered to truly deliver value for our owners. So as a general contractor, I'm going to go back fairly quick here. As a general contractor, we don't do hard bid projects. We do, I should say, especially in our East Coast offices. But most of our projects, 90% of our projects are repeat clients. They're negotiated, no hard bid. That's not the type of work we do. Okay? And so our projects, we look for value that we can deliver to the owner. So the example we always give, if somebody goes to Disneyland or Disney World, or somebody goes to Burj-al-Fatih, right? You're going for the experience, you pay top money, you pay top dollar to go in and enjoy yourself and get a better experience. That's what we sell to our owners as a general contractor. General contractors come, or owners come to us just for the experience. Okay? The last planner system is part of the lean practice. It brings, these are foremen. So these are all foremen. They're called the last planners. They're the ones who go to plan the work. We bring them and get them involved in our planning process and how to streamline scheduling of projects or planning for projects. I'll skip really quick here on some of this. Integrated project delivery. Bashmandis Hisham, I was very happy to see you, and you're a contract person, and and you specialize in contracts. This is an emerging contracting type in the US. Integrated project delivery. This is a contract, one contract signed by 11 entities, the owner, the architect, the subcontractors, the mechanical engineers, the electrical engineers. We all signed one contract. It's called the IFOA, Integrated Form of Agreement. It allows the entire team to to have one goal, which is the owner's goal, right? So the owner, what goals do they want for their facility? We all work, towards those common goals. Does that make sense? So I'm skipping here ahead because it's just based on the interest of time. So how do we deliver value? This chart is extremely important for us as practitioners, either architects, designers, or general contractors. This depicts the cost of a project. So that's cost and value as well. So the y-axis here is the cost and value. The x-axis is time. This is just the sliver piece when they do the beginning stages of a project. The feasibility studies, the business case, the design, then the construction. This is the cost to operate a facility, and this is the profit of that the owner will gain. What we would like to do is, as a general contractor, get involved at this beginning stage. So what the integrated project delivery allows us to do is be engaged at the beginning before the design starts. So this is not a design build, this is a design assist. And so we help the owner make informed decisions here. So our goal is to inform the design, make the decisions in construction, so that we can later reduce the cost for the facility and maximize the cost, the benefit for the owner or the profit for the owner. Does that make sense? And so that's our approach. Why do we take this approach? Construction industry is terrible everywhere, including the US. The boat is sinking, nobody wants to fix the hole, and everybody thinks that it's somebody else's problem. Right? And I'm not going to fix it because it's their problem. Well, no, we all have to chip in to make sure we fix the problem. So how are we fixing the problem today? Again, we're adopting lean practices, and we're engineering new ways of contracting with owners. Does that make sense? And so our practice of bringing in all practitioners on a project, obviously this is a large size project, this is almost $1 billion hospital. It had 150 people, the owner, the architects, the consultants, the key subcontractors, as well as us, in one room, and it's called the big room. And they're all in one space, collaborating. So bringing people together so that no emails, no phone calls, you just walk and talk to them, and then a decision gets made. Transparency is key, so we've got a lot of metrics, a lot of performance key indicators published and updated continuously. Skipping here, now we come to talk about BIM, right? So, BIM for us, again, is a tool, and you can see that, this is the construction industry, truly, right? And so, it's broken, it's crooked, it's inefficient, these guys are pushing, the cart with a square, wheel, and it's not going well, obviously, but somebody invented the wheel and presenting it to them, and they're resisting, saying, no, we've done it this way, 30 years, and we don't want to change. That's the construction industry, even in the US. That's how it is. And so for us, our first exposure to BIM was back in 1998. That's our office in Portland. We started with that, and we're here today. So we model what we build, and we build what we model. So that's a model of a hospital. I think this is everything that when somebody talks about BIM, this is what they see. So, but what is it? Conventionally, we're used to, how many architects are in the room? Wow, good crowd. So this is what architects produce, right? So they produce two-dimensional plans, and they produce elevations, and then schedule of values, not schedule of values, they produce schedule for finishes, finish schedules, and maybe, some door frames and hardware schedule as well, right? So that's what it looks like. It's a little different. Well, if I ask you, what is this? Vishnu, do you know what this is? Okay, so it's like asking people blindfolded, describe what an elephant is, and so this guy touches the trunk and he's going to say it's a snake. This guy is going to touch this and it's going to say a broom, right? But the elephant is an elephant, so those objects are truly these elements here. So that's the first aspect of BIM, is visualization. It allows people to grasp what is it. that I'm trying to build, right? And so obviously that's an isometric, right, of the color, the geometry. And so BIM truly allows people to see the geometry visually, and visualization is key on it. However, it's not just the geometry, so that's the floor plan we're used to, right? It's, and that's door 170, and that's the schedule, right? All of you have seen these drawings, right? You're familiar with it. I see only a few hands. Yes? Okay. So, what if I presented this to you in a 3-dimension, like that, but it's actually a parametric model, and all of the specs are contained within the model. So that's essentially what BIM starts to look like, right? It's a 2-dimensional drawing, now you pop it up, it's a 3-dimensional drawing. Well, now it's a 3-dimensional drawing, where's my specs? Where is everything? It's actually part of the components, the objects themselves, right? The columns, the doors, the frames, the beams, the light fixtures, and everything else. I think Dr. Nawari did a great job outlining the timeline, right? I started with a diamond hand drawings, right? And then CAD, 2D CAD, 3D CAD, and then BIM, right, but how did we really get here? It's like a light board with Kodia. Yeah, and so that's where we started, right? And so we had a light board, and you bring in all the electrical drawings, the mechanical drawings, and this is truly one of the DPR trailers way back in the 90s. Okay, and you try to coordinate the different elements, like this looks like there's a duct running here, and then there's light fixtures, and there's some, sprinklers maybe. But this was an inefficient process. Is this a lean process? No, right? Because it's manual, it involves people, digging deeper, but what did it result into? It resulted in things like this, disasters like this, right? Is that you've got a sprinkler system going through a duct. So, now where are we today? We build everything, every piece. Okay, good. So every piece is coordinated, and then we go build it out in the field. Does that make sense? And so you model it virtually, then we go out and build it. Something like this we would not have been able to avoid. That's an architectural handicap grab bar, conflicting right with the riser, right? And so something like this you wouldn't have been able to catch on a 2-dimensional drawing. It has to be visually looked at 3-dimensionally, and then, why am I pointing only on this side? And then it gets moved, right? So you're looking at all these different virtual mock-ups. We're able to produce virtual mock-ups and walk. So this is an operation theater or operating room. We're able to walk the nurses, the doctors who can't see things 2-dimensionally. And they can actually really look at what the different components are and what does it mean? And what is it if I moved it 1 inch to the right or 1 inch to the left? I want to make sure, there's a couple of videos, I want to make sure I didn't miss them. So that's good. And then again, some of the areas where it helps us is that if there is a conflict, but we can't actually move it. And so for those of you who are far back there, this is a beam, and this is a sprinkler system, right? A sprinkler pipe that's going through the beam. Unless we drew it three-dimensionally, we would not have discovered that that's the situation, and then engineer around it, right? And so this is a solution, so it has to go, that it can be moved. It has to be, engineered like that, and then that's how it looks physically. So it was engineered to have a hole in it, and then the pipe goes through it. We do concrete, so we model some of the concrete formwork, and then we go pour. There is a video here. So Dr. Nawari talked about prefabrication. So this helps us, because now we can get to a very precise size of elements, right? So we can know exactly what the stud height is, what the door size is, what every inch and millimeter looks like. So we've been able to prefabricate just using models like this. Hopefully this runs. Doesn't have a sound. So this is for the Stanford Lucy Packard Hospital in Palo Alto, and the bathrooms were actually engineered, so these are double bathroom. They were prefabricated in Phoenix, Arizona, because it's cheaper for us to do. And then we moved them by truck to the Bay Area. So could we have done this without BIM? Maybe, but with BIM it's more efficient, right? Because now we're able to get to a degree of certainty about the sizes and all the elements that go in it. This is a head wall in a hospital, so again, prefabrication. I'm going to skip some of this. This is key. Our BIM practice is a lean BIM process. We involve the right people, the right time, and in the right place. And at the same time, we model to the right level of degree. So we don't model everything. We look at exactly what do we need to model, and then we go ahead and model it. Reality capture, I'll start with this slide here. Anybody familiar? I think not the ones who were on Sunday. Laser scanning. Okay? So laser scanning, this model specifically is a Leica scanner. And so it rotates and it shoots laser beam around, millions of points, and then it collects them, come back. We can build a model from an existing, building, and then we can produce a true model then that we can produce and interrogate to get out information from. Now, it's not just for interiors. This is an exterior building that we were involved in renovating the interior and exterior as well. You shoot the laser scan, and then you're able to put some skin around it, and now you're building true objects in the model, and then this was pulled into Revit. And Revit, I'm sure you guys are familiar with Revit, so that's a true Revit model. And so if you take the example of like so this would be one way of producing records from something that exists and you don't have drawings for, right? So you can just use the laser scans. Skipping this is interesting. So right now we're experimenting with reality capture using drones. These are drones. That's a $4,000 drone with a GoPro camera on it. And what we do is we fly the drone, so that's the flight path. And then the drone is able to capture the images, and that's a real model. So that is not a photo, that is a real model that I can take measurement. I can actually discern what the excavation depth is, what dirt, how much dirt has been moved, how much dirt has been filled, and it begins to give us some more information about the progress of the project. Make sense? So this is still in its infancy. عم يسمع الطلبة شغلت اليوم الدرون بتاعي صغير كذا الجماعة عجبتهم بس. All right. This is another one. So augmented reality is kind of an emerging field. This is like magic, right? So see that? So that's Justin, my colleague and friend. He's basically rotating a piece of paper and a model just pops up on the screen. Technology is still not there yet, and so this is truly for visualization today. It's not for any other purpose. That's a lab, and you can see the fume hoods and some other things. So as a company, like I said, we experiment with things. We experiment with a lot of things, a lot of toys. We spend a lot of money as well, so that's part of the, virtual, augmented reality. That's a steel building with the model superimposed in it, where you can see and begin to understand, does everything fit? Is everything going to go in the right place? Maybe, maybe not, right? And so it's important for us to understand where everything goes so that we can install it right the first time. Because if we install it wrong, that means we're going to take it apart, put it back again. It's going to cost money. It's going to take time. It's not lean, right? So augmented reality has existed for a long time. You see these lines here. This is not new. It's been here. Construction just didn't adopt it, quick enough. We have a robot currently under development that actually is no more than a printer, not to make it, sound more complicated than it is. It's a printer. It takes basically the information from the BIM model. We send it to the total station. That's a Trimble total station. And then the model basically prints out the floor plan on the floor so that we can go lay out the metal studs and everything else. Make sense? Skipping some of this. I'm going to quickly skip this. I've got 5 minutes to go. I think 2 things to highlight here to conclude with. Again, BIM is not more than a tool to us, at least as a general contractor. Others may disagree. What's more important for us is the people that use the tool and the process we engineer around the tool. We've implemented technology before as a company, and without regard to people and the process, it failed miserably. And so if anybody here got any inclination to go try to use technology, please bear in mind impact to people and to the process as well. If you ask me my personal opinion, I think implementation of BIM is 50% sociology, literally, 20% maybe 30% process, and 20% the tool. The tool, you can buy the tool, you can pour money at the tool, right? And you can get the tool. What you're not going to be able to get is the process and the people. So spend time to engineer the process around the tool, spend time to educate the people, and also, change the behaviors. This is a complete paradigm shift. There was one here. This is another one that I think it's good to talk about. Again, we talked about BIM as a visualization tool. Use it for coordination and making sure that clashes and the different components of the building don't conflict with each other. You can dig deeper. So these are the levels. You can start here. Absolutely, and you will gain a lot of benefit. Right? Just make it a visualization tool for the 3-dimensionals. That's it. Then you begin to add more information into the model. You can start to use it to coordinate between the different trades. You make additional and more details in the model. You're able to then look truly through constructability and how the components come together, and do they work? Maybe they don't. And then you can go down to the level of prefabrication. So, I think to conclude this, for us, BIM is not about just geometry, the 3-dimension. It's basically about the data that's housed. It's about the I. So BIM is BIM. It's about the I, which is the information piece of it, right? Today, for us at least, the geometry doesn't do us any good anymore. I think we're beyond that. We're looking at the information that's contained in the model. Thank you.
دكتور معاوية جزاه الله خير ما قصر، لكن هو عدنا بكيس استضي، ولو الشباب وافقوا يعمل لنا ملخص سريع كده في ربع ساعة ولا 10 دقائق عن الكيس استضي.
Right, emotion. Okay. خلاص كويس.
تقولي في لكن لو مش فاكر. Just kidding. Okay, so I've got 3 projects here to show you. So this is the Camino Medical Center. Like I said, my specialty is building healthcare projects, so I pick, 3. We'll see how the time goes. Who's timing me? Somebody needs to time me, otherwise I may go over time. So this is the Camino Medical Center. This is a $102 million project. You can read through this. I'm not going to bore you with my reading. We've used BIM. We've used lean practices. This was not an IPD project. This was a traditional contract. It's a form of a contract called GMP, a guaranteed maximum price. And we can go into details what that means. But the results are telling. So this hospital was built, the cost of the hospital was $9 million less than what the budget allotted for it is. We had 0 conflict RFIs between the MEP systems and the fire prevention system. We have achieved only 43 hours of rework. Obviously it's construction, things happen and things change. And so out of 25,000 man hours spent on the project, which I think this is tremendous. Productivity has been improved, right, on MEP between 15 to 30%. And I'll show you another case study which actually details this a little bit even more. So this is the second one. It's the Sutter Medical Center in Castro Valley. This is a $320 million project. This is a true IPD project where all 11 partners signed the one contract. And so these are the 11 partners, and we've made, are you familiar with the ENR? Okay, so the ENR is